In Unix, file systems are organized as a series of abstractions. The top one, and the one that we're pretty familiar with, is that of a path. A path will look like something like /home/file.txt. Usually you might have a few more layers here, but just for keeping our examples short, we only have home file.txt. The path itself is made of individual parts, each of which is a different file name. So slash is a file name, home is a file name, file.txt is the next file name. And so those will represent the second layer in our hierarchy. Below the file name, we'll have the inumber, or the inode number. The inumber tells us where to go look into the inode table to go find the inode structure that will give us all the information that we need to be able to find a file on the hard drive. That information includes the block numbers. The block numbers actually give the hardware enough information to go find the data on the hard drive. Block numbers are actually not the end of the story. If you have a hard drive with multiple blocks, the block number would then be translated to a specific platter and maybe a specific angle of rotation for that specific block. But as far as we're concerned, block numbers is going to be the end of the story for us. So what I'm going to do here is I'm going to represent a small hard drive, a series of blocks, and then we're actually going to go through finding this file, /home/file.txt, understanding how we go through that process by going through all of these layers. So this is going to be my hard drive, and that's going to be divided into my big blue blocks. And I'm going to put a whole bunch of these. These are not necessarily going to be consecutive, just in order to illustrate it. And I'm going to put ellipses just to show that we can sort of like distinguish those. And so the very first block is going to be 4. You know, there might be some blocks before. So this is going to be 5, 6. I'm going to put some blocks here. 14, some more blocks, 23, some more blocks, 61, and so on. At a well-known location on the hard drive, a location that the OS knows ahead of time, will be the I table. The I table is what we use the inode number to index in. Let's say that it just starts at the beginning of block 4, and let's say that inodes are pretty small, but we can only fit 4 of them per block. And so we're going to have a bunch of inodes per block. And this would keep going on. So this would be inode 1, inode 2, inode 3, 4, and so on. Now, the last thing that we need to be born knowing is where the root is. And the root will have just a well-known inode. So in this case, let's just place it at 1. The inode contains a bunch of information about the file. It tells you if it's a directory. It tells you what permissions are set. It gives you a bunch of metadata. And importantly, it gives us the block numbers. So in this case, let's just say that the block numbers are 14, 37, and 16. This means that to read that file, I go to block 14, read out block 14. Once I read the end, if I want to keep reading it, I'm then going to go to block 37, and after block 37, block 16. I'm not going to represent the later blocks. I'm not even going to write 512 bytes worth of data in this tiny little space. But I'll show you just how it's structured. And so in this root folder, which will be slash, right? This is really where the root lives. Will be just a listing of different folders or different files and the inodes associated with them. So for example, home will be in there and might have an inode of, say, 6. The Etsy folder might have a different inode. The proc folder might have another one, and more and more. So this will be, let's say, 7, and this might be 4. So now that we're interested in /home/file.txt, we found the inumber for home, and so we can go look it up and just repeat this process again by going up and across these layers of abstraction again. All right, so inode 6, that will bring us over here, and let's say that the block numbers that we have associated with the home folder are going to be 23, 28, and that'll be it. So now at block 23, I can go look to see what files exist within that home folder. So again, this is 6. And over here, I'm going to find a list of file names, including file.txt. And maybe, I don't know, hands-on, classes.txt, and a bunch of other files. And these will each have an inumber associated with them. So let's say that file.txt has inode number 2, the hands-on might have inode number 12, classes.txt might have inode number 8. And then we repeat this process again. We go to file.txt. We go to the I number 2, which is going to be represented by file.txt. So this is home. And so we go there, and we'll see that it's associated with block 61, for example. And once I go to block 61, I'll actually have the file. So this will correspond to /home/file.txt. Inside of there will contain the data that I have. Just something, for example, like, well, this pen isn't working. Hi, 6033, and the rest of my recitation notes. So the key point that I want to highlight here is this jumping back and forth across all of the abstraction layers and going to the directories, which again are files. We read the inode number, go back here, get the block number. We're able to go use the file number to find the inode number and wrap back around until we fully expanding this hierarchical path. And this really allows us to have folders within folders and files within those and really have this flexible file system. As files grow or shrink, we just find the next free block and just grow that down there. So if we say that, for example, block 15 is free, and I keep writing stuff into my file.txt, I would then say, oh, OK, block 15, you're going to go, and I'm going to add you at the bottom of this. All of this will be transparent to the user, and we can have files that grow, that shrink, and we never have to worry about all of this.